another draft physics video presentation. So I guess I will clean up any other residual counter arguments that need to be made on the two-slit thing, and I think I will proceed to attempt to itemize and document all the facts that basically prove that it is fallacy to believe light is doing anything wave-like, and that it is in fact quantized momentum moving on standard vectors, and light scatters when it hits electrons, and that has a consequence, and the consequence can explain what is seen in the experiments clearly. Anyway, so this is somebody brought up truth or kind of 9/11 kind of conspiracies in the comments, and that's what this all smells like. It's this whole looks like is like phenomenon, seems like is like, however we want to describe it. Superficial, no effort to pick at the details to see what the real truth is, just real superficial mistakes. And of course these mistakes always come with agendas, like the Ken Wheeler in his ferrocell. Looks like light is getting bent. Lots of people fall for it. Is it anywhere near the truth? No. So this is the same kind of thing, except it's even more obvious, I suppose. The experiment isn't that complicated. It's not that much going on, not that much to analyze, and that's where we are. Conventional physics is Ken Wheeler-ish. It's flat earth-ish, and they spend a lot of time picking on competing theories and seeing their gaps and their weakness, and they don't want to physician heal thyself. They don't want to look inside and see how much corruption is in their own perception, how many times they have fallen for the looks like is like mistake. So anyway, so he first says light exhibits wave-like properties. No, it doesn't. So it depends on what you call a property, right? So all we have is an on-off pattern, and basically they're saying that anytime I see an on-off pattern, I'm going to say it's interference, wave interference, and clearly that's way too looks like is like. You should know better. I mean, it's like saying everything with fur is a rabbit. It's just not very sensible. Clearly everything that has a bill is a duck, because we know the platypus exists. So anyway, we can observe single slit diffraction. So let's understand what diffraction is traditionally. Diffraction just means really it just means a kind of reflection, a kind of deflection. So it's kind of like the word deflection. It's basically just saying that something can deflect in any one of these directions, and that would be a diffraction. So it's going this way, and if you do it enough times, it'll end up going in all these directions, and equally in such, and that would be diffraction. And in waves, that's what you're going to get with a single opening in water waves, as long as you don't overstimulate the water. See, water is molecules that are stuck to each other, okay, so they have a bond, and the fact is they have to move. These whole atoms have to move in water. Whole atoms have to move, not little things. Whole atoms are kind of big things, in physics, and they have to move, and it takes time for them to move, because they can't move anywhere near the speed of light or the speed of force. They move much slower. And if you try to move them too fast, they can't do it, and this adhesion between them breaks down, and so then they don't move collectively. See, they'll tend to move collectively, because anything that pushes on one, it's tied to the others and it drags them along. So you can sort of understand that a necklace of beads or something, if you push on one of them, the rest of them will go along. But if you push too fast, faster than they can spread, their movement, then they'll break. The necklace will break, and two beads will go this way, and the other beads will go this way, and the beads will go in separate directions. And so that's something anybody who has any, like, high school physics could sort of understand, that water has its limitations, just like sound. You know, the atmosphere has its limitations in terms of its carrying speed, and water has the same limitations. You know, it has limitations, it's just not the same ones. So if you try to stimulate water too quickly, it just agitates, and it's called splashing. It starts splashing. I mean, little bits of water will actually fly in the air because of the fact that the speed is no longer being transmitted to all the atoms and turned into the same speed. It's getting very variable different speeds. And obviously, if you're agitating the water with a big flapper here, you're banging into the water as it's coming into the flapper. The flapper's moving this way, and that even accelerates the molecules even faster. So you're adding acceleration. You keep making water that's faster and faster, and so none of these waves are ever waves anymore. They're just a broken bunch of waves that end up going through the slit. And so obviously you'll get pieces that'll go this way, and you'll get pieces that'll go this way, pieces that'll go this way, and you'll get all kinds of different broken pieces. You won't get the consistent wave anymore. But anybody who knows anything about physics, if I drop a rock into a pond, I'll get nice, consistent waves. Now, if I throw the rock into the pond, okay, I'll still get consistent waves, but what I'll do, I'll agitate the water so much that I'll have some of the waves out here way ahead, because I'll create all kinds of, I'll project the water actually through the atmosphere faster than it can move in the water, the force, and I'll actually start creating a bunch of extra waves. So I can create noise, all right? But we know that if I do it just the standard way, with standard mechanics, I'll get nice round waves. And the same was true for, so there won't be any changes, there won't be agitation. So it's basically garbage in, garbage out. If I put noise in, I get noise out. If I put something quiet in, something standard and reliable like light, okay, the frequency of light is quite dependable. Okay, so there's not a bunch of blue and green and red, lots of colors at one time. And color really isn't a great example, just because color isn't noise. I mean, they're still nice straight lines. The fact is that it's the breaking that's the problem. Having one wave front that has more than one color in it, so to speak, would be the problem. But the fact is you can fully understand that, yes, you can do an experiment, and you can do it right, to show diffraction, you know, standard wave diffraction, or you can break the physical dynamic and create like a sonic boom or something. You know, you can go beyond the limits of the medium, and you can create a different result, and then you can quote mine that result and say, there, that proves that it's in wave interference. But I don't think any degreed physicist would say that when you put a bunch of noise into a single slit with water, that you're getting wave interference as the outcome. I don't think they'd say that. I don't think they'd call that an interference pattern, in all honesty. I don't think they're that dishonest or that stupid. So when these chuckleheads, you know, quote mine the physical evidence and find, I mean, it's, you know, there's actually absolutely, it's perfectly sensible for people doing these experiments to see how much they can put, how much energy they can put into a system and see what the results are. And it would be perfectly sensible for them to document it. Now, it's not sensible for them to imply that it's wave interference. And I don't know if MIT exactly did that. And if they did, they're guilty of being stupid, because it's perfectly explainable why the experiment breaks down. All right. Anyway, we can observe single slit diffraction and double slit interference in water waves. Now, the point being raised clearly is what you can't observe in water waves, and okay, it just doesn't physically actually in any way actually happen, okay, is that you can't put the two waves in, do your wave interference idea with water, and get the pattern that arises in light. So we know this is the pattern in light. You know, it's doing this well, I'm not drawing that well enough, so we'll redo it. So we get this center blips, and then we get these peripheral blips. So we're getting two fringe patterns. These fringes plus this whole envelope fringe pattern. Alright, so there's two patterns. Now we know water doesn't do that. And this is a startling fact. I mean, it's not something you can just dismiss as, oh, I don't have to explain that. No, you do have to explain that difference. It's a huge difference. And again, water is doing this. This isn't on. This is on off, and this is just off. The dark spots are just off, and then it's on off, and then just off. I mean, in water, it's not just off. It's a half a hump. So it's not a crest or a trough. It's in between a crest and a trough. So water's not doing the same thing anyway. But all they're counting, all they're seeing, right? Because it seems like all they're seeing it as, okay, as something, nothing, something, nothing, something, nothing. And they're saying that simplest pattern you can make in the universe, on, off, has to be wave interference. And, as I'm stating, it's obvious that lots of things can create the simplest pattern in the universe. Lots of things. Okay. So water waves do not create the double slit pattern. So it's wrong to say double slit interference, because it's not the same interference pattern. It's just a lie to imply the two patterns are the same, because they're not. Okay. As I don't know, waves is light? No. As okay, in water waves. Alright, double slit interference in water waves. What the hell did he write there? As well as, okay, as well as light. So again, it's not the same pattern, and so that's just being, that's going, ferrocells look like they bend light, so they must bend light. No. Alright, Gary provides zero evidence. Doesn't make any sense. I'm showing the experimental results and showing with drawings how my theory fits the experimental results. That's exactly what you do when you make an argument and you attempt to prove it. You show the piece of evidence at trial. You say, here's a gun. It had his fingerprints on it. Okay, that's what we found. We found that he has an index finger and a hand, and he could hold the gun and pull the trigger. You explain how the evidence indicates, a certain cause to the end effect, and you explain how it fits, how the theory fits. That's my obligation. I've satisfied the obligation in the sense that the theory fits the evidence. It fits the outcomes of the experiments. Your obligation is to show an experiment doesn't fit. Okay. To support his claim that light is a particle. Well, I've already explained this whole word light is kind of underdefined. So when you say light is a particle, clearly I'm arguing, and have always argued, that light is made up of particles. Even when I thought light could be, the frequency of light would be a whole object, right? And that would define the frequency, and there was no space between them. They were just big, giant objects, right? Which was wrong. And then I realized, no, it's the empty space that's the real thing. So there's just a little bit, and then another little bit, and then another little bit. So I've consistently been saying that for at least 7 or 8 years, that this defines a photon, okay, these little bits at a frequency, and that you have to have a certain number of them, which is completely consistent with scientific evidence. A photodetector or photomultiplier or a photodiode can see just, all you need is 3 of these or something like that. All you need is this much of a ray. And clearly our human eye, from what they've figured out, needs 6. At least 6. 1, 2, 3, 4, 5, 6. Alright, so in a frog only needs 4, let's say. But there is a length. It's a photon. This is a photon. All right, this can be a photon to a frog. This could be a photon to a photomultiplier. So it's not as simple as just saying photon is a particle. Nobody's arguing that. I don't even think Newton argued that. So, because it's known to have a frequency. Okay, so it wouldn't be a single particle. And so Feynman says it comes in clumps. Well, it comes in, an event. It's not really clumps, right? You can clump that, and we'll call that a photon, and say that our eye can only see the ones that have 6 of these things, and it's not a clump if it doesn't come with 6 of them. Well, it still is a clump, right? It's just not a photon clump. So, I don't know how you want to, argue this particle thing. Okay, you want to say that you can only argue particles, and a photon has to be one giant particle that somehow has a magical frequency. The whole particle is the frequency or something. So the particle would be, so if it's a 500 nanometer piece of light, that this would be a 500 nanometer particle. And then there would be space, and then what? Yes, it doesn't even make sense. So this is what they want to just straw man the argument. They want to say you're saying something, you're saying XYZ when you're not saying that. I didn't name photons, okay? It's unfortunate these mistakes are made in physics. The idea of a quantized, the fact that there was a certain amount of energy that you needed to make photons out of, that is, there was a difference between having 5 clumps and having 5 units of energy and having 6. We could see 6, we can't see 5. The fact that it's all contingent on that little quanta, or that the fact that the energy increase always comes in a clump, so to speak, doesn't mean the thing we call a photon is a clump. It's a chunk of something, right? And you're stuck with the same argument. Your wave theory is basically saying the same thing. Your physics never talks about it. Why don't you do an explanation of what a photon is? Is a photon one of these things? Do you think that's a photon? Or is a photon 10 of these waves, or 20 of these waves? Why don't you show me the video on YouTube that explains what a photon is in terms of waves? How many of these waves do I need to have a photon? Because you always draw it with at least 3, right? I don't think I've ever seen a photon drawn without you putting more than one of these little wavy things in here. What do you think it is? Do you think it's this much, or do you think it's this much? How much is a photon by your own theory? So there's just such duplicity here, double hypocrisy, if that would be a good word for duplicity, double standards. Physician, heal thyself. You're going to make these claims. Why don't you explain what is a wave? In the sense of, how do I make a wave into a photon? When is a wave not a photon? I don't know. How do I portion your wave into a thing called a photon? If I was to draw a circle around your wave and say there's the photon, where do I draw the circle? All right. He deliberately mischaracterized the argument that light cannot, can't, be a classical particle. Well, what argument is there except you're asserting something and you don't have any evidence to back it up? So where did you demonstrate it can't be? Where did you do that? Oh, that's right, you didn't. And it can't be means you have to disable all possible particle explanations, not just one said by some guy named Joe somewhere. You have to say it in some way that somehow there's some reason why particles can't. No matter where you put them or how you arrange them, you can't possibly arrange them in any way that would duplicate the experimental results. So that's a pretty high burden. I don't see that you did anything on that subject. You certainly haven't in any way pointed out how my description of the particles and how they function doesn't work. You didn't do that. That it can't be, that you proved it can't be. You have some fact that means it can't be. No, you don't have any such fact. All right, so in his video, he's doing the, well, when there's one slit open, it makes this pattern, and when there's this slit open, it makes this pattern. And how do you get dark then? So it's light here, so it's really intense light at this location, let's say, when one slit is open, and then it's intense light here when the other slit is open all by itself. And somehow when both slits are open, there's no light here. Now, that would, if that were true, well, you'd have an argument. At first, he drew this really poorly because he puts the deficit almost in the middle. But anyway, yeah, if it were true, that might mean something. But, you know, again, you're the one providing no evidence. You're just asserting things. So first, you didn't prove that one slit makes this, and then one slit makes this. You didn't prove those things, and then you didn't prove that when you put the two slits together that those two things go away and you get this deficit. So, you know, this is where details sort of matter. So they have done the experiment, actually, you know, where they move a, I should draw it just to be clear what it is. There's lots of different ways you could have done it. They could have done it with just putting a plate in front of it and sliding that across, but it does create this problem that when you try to cover a slit, you're actually covering it with another slit, another wall, another surface. And as I've pointed out, the surfaces are what's messing up the pattern. So the idea is, though, that you have the two slit experiment, and then what they do is they take a thing, okay, that has a cutout in it, all right, an opening, and the rest of it's closed, okay, and so they're going to move the opening so it opens, you know, there's a two slit pattern, and it slowly opens one slit, and then as it moves across, it finally opens both the slits, and then it kills both the slits. So it's a, I should have drawn this opening bigger, I suppose. So you can just see as you move it across, you start with nothing, you slowly have one slit, then you introduce the second slit. Would be the idea. And this is the results you get as you do the experiment, blah, 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 blah. And you can see that there's the two symmetrical where the single slit is one slit is open, and it has a little bit of a fringe because they have the thing at a different, you know, some of the light sneaking through, obviously, creating fringes on one side, which is perfectly understandable. But anyway, so when you have the two bulges, the bulges end up on top of each other, right? The blobs of the single slit, and obviously it's not a very good single slit. Okay, it doesn't have more than one fringe, so it's very weak light. So that has to be conceded here. Obviously, it's very weak light because the fringe is very weak. Yeah, we don't even see it on the other side. So when one slit is fully open, we barely have any fringes on the other side, none at all on one side. So it's really weak at this point. But what you can see is that when they combine the two, when you have both slits open, you can see in this pattern that obviously the dark bands don't even exist between the little dots. You can see that it's added light, not subtracted light. So there is no dark line between them. Now if you wanted to get the dark line, you can, but you modify the experiment in the sense that you have to send less light. You don't get the saturation. See, that's a saturated image. But if you go to non-saturation, then the problem is that your two open slits aren't in the center of the light source. So what you're really talking about is you have your lights coming in, and it's not coming in even, right? We know that the light sort of has a coned effect, so it's weaker light over here and weaker light over here, and this is the strongest, the highest number of photons here in the middle, less photons over here and over here. And so the truth is that the weaker light's going through the slits, not the strongest light in the two slit experiment. But if I did a classic single slit experiment, obviously I'd have the light source right in the center of the slit, so the strongest light's going through. And so that's all you have to understand. It's really about when you're going to saturate the image. But the truth is, I would assert, the honest truth is that if you, however you do the experiment, you'll find out that this really is just additive. That the one slit is producing a pattern, the other slit is producing a pattern, and the fact is that when you allow the both slits to affect each other, you're just adding light because you're adding an extra source. The single slit only has 2 sources. The double slit obviously has 4 sources. And from each point, the important thing is each point has 4 sources. And so you're just adding light at locations. So you're just making these things are just the addition of the light from this source and this source. This light, this background light, is coming from these sources. And obviously when you cut it into a single slit, those 2 sources aren't the ones creating the pattern anymore. You have just these 2 sources, and these 2 sources can only do this and this. So now you have this extra source of photons, 2 extra sources, 1 and 2, when you add the second slit. And so all you're doing is adding light. You're not subtracting any. So you won't be able to do the experiment where, if they try to do the experiment where they have division between those little circles, that is the circles, if they try to do the experiment so they turn the light down so they're not saturated in the middle, and so if they get the nice clean pattern with the middle, and they do exactly the same pattern, exactly the same experiment, so, and they have nice hard darks here, nice hard dark here, nice dark here. If they do that, I'll predict, okay, I'll tell you the truth is going to be that when they move the slider across, they won't be able to see the humps, the 2 humpy things, the 2 little blobs like this. You won't see them. They'll be very faded, very faded, and that's my prediction. So the only way they could make it all visible is they had to oversaturate, and if they undersaturate, if they reduce the saturation, that is, they make this definable by reducing the light as a dark, then they'll find that the single slits are very weak, and they'll be very, very weak or invisible because there was so little light. So that's my prediction. But there is no magical light was going there and now light can't get there. That doesn't happen. That's my assertion, and until you can provide evidence, it's a perfectly reasonable assertion. So prove me wrong with an experiment, with a piece of data, with something real, not just your sloppy drawing. Alright, so that's probably enough of that. So the Skyrom guy didn't respond. I guess we'll read one of this snarky comment and deal with that. So he does this, reminds me of 9/11 conspiracy people. Alright, so he's reading somebody else's comment. And, clearly this is our prerogative. I'm calling you people idiots. Okay, it's okay for you to call me an idiot and say I'm being the idiot. I'm just saying who's being fair to the evidence. I can demonstrate you're quote mining it. Okay, you're cheating it. And I can also demonstrate that unlike this perception that there's this real physicist out there doing this right, I can show all the most famous physicists saying things that just aren't true. Talking about detector experiments that were never done, and Feynman talking about the 2 clumps being in different locations when clearly they can't be. There's no reason for them to be. There's a 1 millimeter difference in the slit position. The light isn't going through them sideways. Okay, so all there can do is be a 1 millimeter difference in the pattern. Same mistake this idiot or this other guy made. Where he has to do his revision to fix his mistake. But yeah, that's all you can do. You can make mistakes. Now, you want to point out where I made a mistake in this most recent argument? I have made mistakes in the past. I was trying to make something that can't do what I was saying it was doing, do something it can't do. I thought it could. I mean, I wasn't doing anything dishonest. I thought it could work, and I found out it didn't. So, you want to drag up stuff I said 7 years ago, fine, but I'm just saying that's your prerogative. I mean, I really don't want to delete content, and I don't think I really have an obligation to, in simply stating that I've improved the theory with time. So I would prefer, if you're going to argue that I'm wrong, that you actually use my theory of photons, not somebody else's or a much older version. But anyway. So here he says, a desperate science denier. So again, okay, and I'll call you the same thing. You're an intelligence denier. You don't know what the scientific process is at all. It isn't quote mining experiments, that's for sure. Every scientist, all the great scientists of the past would have agreed. You're not allowed to quote mine your experiments. You're not allowed to say, well, it worked on Tuesday, so I'll just accept Tuesday's results, and even though it didn't work any other day. Yeah, you're not allowed to do that kind of crap. Okay, and I can prove you're guilty of that kind of crap. Superficial analysis. You're just good doing the seems like, looks like, is like bullshit, and doing it all over the place. Alright, denier comparing a wave tank at MIT. So again, MIT also has the wave tank doing the waves right. So they have both versions. You've just chosen the version where they were way, and I showed it. I mean, I showed the noise, so it's quite obvious what was going on. That there was way too much energy going through the single slit. It wasn't a plane wave anymore. So my argument that plane waves do not create interference patterns with a single slit in water is still completely valid and solid as an argument. And you have to defend why you need to you have to create something other than plain, consistent waves to make the pattern you're arguing is something fundamental. So I would argue it's not a fundamental function of waves to do that. You're breaking the waves. They're wavelets now. They're not even waves. They're pieces of wave. Anyway. To 9/11 conspiracy theories. So again, this is an overstatement to say that all the MIT experiments prove that no plane waves ever come out of a single slit with no interference pattern, no diffraction pattern, whatever you want to call it, no pattern. They come out plain and round and curved, no pattern created. Are you asserting that MIT has no such experiment? No, you're asserting that you can quote mine evidence to make an invalid argument, frankly. To be a propagandist, then that's all you're doing, right? It's just propaganda. You're taking one little tiny fact, hugely exaggerating it to make your argument. Not the consistent indication of what happens. You're taking the inconsistent result. Like when I roll dice, and I could roll the dice and 3 of the dice stack on top of each other. I could take that inconsistent result and then try to say to people, yeah, when you roll dice, they stack on top of each other. Here's the evidence. I videotaped it when it did it once. So, you're saying that's being a good scientist. You're not a science raper. You're not something worse than a science denier, a science corrupter. You're defending a pretty corrupt method of doing science, aren't you? Yes, you are. Okay. I'm actually surprised that the YouTube algorithm hasn't auto-blocked his comment yet. So amazing. It's just so anti-science to point out a fact. Oh, okay. That he's not a 9/11 truther himself, right? So, we're the truthers, and I can show how, no, you're the truthers, because what did truthers do? It looks like a bomb on the plane. It looks like, isn't that all they have, is a bunch of look-like arguments where, if you're smart, you can say, well, you're just not understanding, okay? The inside of the building already fell down. All that was left was a facade. That kind of simple mechanics stuff. You can see the wind blowing out as the floors collapsed, right? You can see it. So we know that already happened. We know it was already happening when the building looked like it wasn't doing anything. Well, the whole inside of it was actually collapsing. All right. I mean, then you go through all the chemical analysis and all the other stuff where, I'm just saying that all of their evidence sucks. It's quote mining. All of it. All right. I mean, he's the one praying to the altar of the physics guru. So again, I have to be labeled something that I don't label myself as. Just in an effort to, why don't you be a Ken Wheeler and just call me a fuzzy-haired crackpot? That's the best you can do? I mean, you're in every way behaving as if, as Ken Wheeler, right? Because all you have is insults. You don't have anything else. Okay, living in his auntie's basement. So I guess that's like Tesla saying, Einstein was in his purple robes or whatever, some other kind of bullshit, whatever that means. So all you got is insults. You don't really have any kind of evidence, right? Right. And claiming all of physics from the days of Copernicus. So that's a lie right there. It's just an overt one, right? I mean, it says right on the first paragraph of my, website, that I'm saying that no, Newton was a good physicist. Okay, he didn't go beyond the evidence. He didn't assert things he couldn't say with a great deal of confidence because he believed in that scientific method of being careful. And so did a lot of these guys. A lot of these guys had theories. Faraday had a whole gear theory of electrodynamics, spinning gears. But he never asserted this was the right answer. He was just speculating. And he labeled it speculation. He didn't assert a truth and say no other truth is true because I assert that it's gears. I mean, those were good scientists. And I'm saying, yeah, that's when the good science stopped. And then in the 1900s, everybody was saying, well, you get very famous, you can get very popular, and a lot of stuff if you can just answer these questions. And so what if your answer is wrong? And that's pretty much what it came down to. We're frustrated. We can't figure out whether it's a wave or a particle, so let's call it a dubical, a bothical, and just move on. But we really believe it's a wave. But we'll just make some mild concession to the fact that, oh yeah, sometimes waves don't work. I mean, you're the ones that broke the physics. I mean, you're the one defending the sloppy and lazy, crappy things like the Eddington experiment all of a sudden proves there's a time dimension. No, it doesn't. All right. To present day are in a cabal. So again, never stated as any kind of cabal. It's just that people can have crappy and shitty parents. And you've had crappy and shitty parents that raised you to be a lying piece of trolling scum. And the same thing can be with physicists. They're not raised to have integrity, to be careful, to be cautious, to honor their science, to do their best, not to cite experiments that never been performed, to do some research, to know what the fuck they're talking about. Obviously, physicists are raised to be arrogant little putsy nerds who think they're in some sort of elitist ivory smart tower. And they're just so full of their, I got all kinds of badges. One of the badges you don't have is, I don't poo my pants. Because you'll poo your pants. I mean, these nerds, they'll make all kinds of mistakes in their arrogance. So it's no cabal. It's just a cabal of being human. Humans, generally speaking, suck. They're glory hunting, competitive. They want to be the first. They want to outdo the other guy, and so they take shortcuts. And frankly, Eddington's experiment was a huge shortcut. Instead of just admitting, shit, we spent all this money to do this thing, and we just didn't get good enough product. We just can't draw a conclusion. The experiment just didn't work. They forced it, and it's just obvious on its face. It's obvious in his own journal comments. The tragedy of it is a documented fact. Okay, that everything that could go wrong went wrong, just about. Documented fact. And yet you haven't repeated it, so you haven't obeyed the scientific method and repeat the experiment with the same quality instruments. So, why do I even have to make this argument? Here you are defending something that's just not defendable as the scientific method. And looking at the two-slit pattern, the scientific method is to first say, boy, that's got an asymmetry in it, doesn't it? Well, I certainly can't create that asymmetry with two symmetrical waves. That's sure as hell ain't going to work. Anyway, cabal to hide the truth about how water waves behave. So again, the water wave argument, I think most physicists could look at that experiment and say that's not a very good demonstration of how water waves function, because all you've done is create noise, and you've shoved noise into a little slit, and you're not going to see how water behaves. You're going to see how droplets and splashes and agitation behaves. Alright, so I think that's dispensed with. These are all just positive kind of comments and such, so we won't bother with that. And so we'll move on to which thing did I want to... Okay, so we have the multi-slit thing. We already did that. So maybe we'll just go back to the math. No, I don't want to do that. Right. Well, even though it's, we should, I suppose, deal with the Wikipedia pages. I think that's what this one is. Yeah, with the bad description of the slits. The two mathematical formulas. Alright. Just trying to think of a good place to just leave it, and I'll just do my thing. So those are two images of the double slit, and you can see one is kind of fuzzy and one is very clear. And one is the single slit, so the same size. But you can just understand that if I'm shining the light through a single slit that's right in the middle, then I'm going to get a different amount of light than if I have the slit over here or have the slit over here. This is going to be more light, that pattern. But if I'm doing the double slit, that background pattern is going to be much weaker because I moved into the less intense portion of the beam of light. Alright. See, lasers really help because it's a lot more even light. So if they did the experiment with the, explicitly, they'd see that if they used the same slit opening and the same laser, those two patterns wouldn't be able to be made with the same laser beam because the intensity of the top one would wash out so much of the bottom one. I wonder if you can link to these images. Yeah, you can. So you can see there is quite a bit of fuzz between these two. There's no real hard darks here, So, and that's the important point, is that it's relatively brighter. It's not that it goes completely dark, completely light. It goes this much light and then it adds more when you have the two slits. So it's not subtracting light from a location, it's adding light to a location. And that's all you're seeing the difference between. So I guess that's what I'll do. I'll go through a brief on what I'm arguing is really happening. So my argument is that photons, and this is corroborated, let me emphasize that the polarization experiments where you take the three films and you put them at different angles and you end up with more light by adding this middle filter, okay, that my theory is perfectly consistent with that result. It explains it completely also. So this isn't, my argument is corroborated by other photon experiments. So let's be clear on that. So I would argue that photons are not waves, they're just quanta, and that the quanta moves the speed of light and is produced by matter in such a way as that the photons have a distance between them that is always consistent. And that consistency is based on, when they're formed, they're basically formed by electricity passing through atoms. And as it passes through the atoms, the electricity moves at a certain speed, the force between the atoms through the electrons, And so it excites an atom, it produces the little quanta. It excites an atom, it produces the quanta. It excites an atom, it produces the quanta. It excites the atom, produces the quanta. Now, producing the quanta just means the electron moved, but I won't get into that. You can just get the idea that it's the electrons, it's the speed of light of the force that's basically dictating the frequency. So the size of the atoms will completely decide the frequency, the preferential frequency that's produced by the atoms. That's why most atoms create light in very, very specific frequencies, is because they have specific locations. And so that's basically the photon, and the polarization is the fact that it went across a distance. So this one was released obviously first, and then this one second, and then this one third, and then this one last. Well, I should have drawn that the other way. So you can sort of see that one of them would be well on its way before this last one even started, and so that would be the polarization. So the light travels the speed of light in a ray in a direction. The quanta have a specific distance dictated by the atoms, and they have a separation dictated by this total distance of the crystal, of the metal, or whatever is creating the photons, the atomic structure that's producing the photons. And so that would be the polarization. So the polarization and the wavelength are consistent with each other. This distance will be proportional to this distance. Out of alignment they are. So they're produced over a piece of material. That's the polarization. And they're at a frequency because that's the speed at which the atoms are interacting with each other, or the speed with which the electricity passes from atom to atom. And that dictates the frequency. All right. So as stated, a photon technically is a composite particle. It's not a elemental particle. The elemental particle is the quanta of force. And by my theory, it's really the same thing as magnetism and gravity and all the other forces. It's just little bits moving the speed of light. And when you put them at a frequency, and you have enough of them, you have 6 of them, the human eye can see them. You have 3 of them, it's these 3, then a frog could see them. Okay, so what is a photon is defined by the instrument that you're using to see it with. Some instruments will see the photon, some instruments won't see it, even though it's obviously the same mechanical thing. So this could be a photon, or this whole thing could be a photon, depending on what instrument's measuring it. Alright, so the idea is that these bits, okay, travel into a system of some kind, and in this case we're talking about, I'll put the slits this way just for, since we have the thing moving that way. And so I'm arguing that this slit is an obstacle course for the photon. The first problem the photon has is this is to scale. Okay, the photon is big compared to the slit. The polarization, this is the polarization of the photon, is this distance often. So the polarization is the size of the slit, which is a problem, and the wavelength likewise. So obviously if a photon, I can't really draw them the way it would be really great to draw it. The little bits are piled on top of each other. So there's one photon here, there's another photon right here, right doing this and doing that, so they're all piled on top of each other. A ton of billions and billions of these little particles layered on top of each other. So one photon would be there, one photon would be here, one photon would be here, one photon would be here, and stacked on top of each other. So some of them are going to just, some of them, their polarization will hit this way. So half of these little bits would get knocked off, would plow right into this surface and die. But 2 of the little bits would still get through. So it just depends on where the photon goes through, how much damage it takes. But obviously most of the photons will be damaged in some way. One of these little bits somewhere will get wiped out by hitting the surface, because the polarization, the polarization is just about the same as the photon. So very few of them are going to get through without being touched at all, without being at all damaged. And so now they're damaged by some absorption right into the material, because the photon is bigger most of the time than the slit in terms of, so some portion gets wiped out. So all you have is a bunch of bits. Well, also now you have the surfaces have electrons on them. I mean, even if you just pay any attention to regular atomic theory, you know the proton is on the inside, the electrons are on the outside, right? So it's kind of obvious that the protons are never on the surface technically, that electrons will always be on the outside, right? You're always going to have a bunch of electrons on the outside of any surface, just based on atomic structure. And so the theory is that, okay, now the photons have been broken, some of them, most of them, and now the bits that are left, so now you only have like 5 bits, and they're missing that bit, and it's got this bit and this bit and this bit. So you have a photon that's still mostly a photon, but it's missing one of its elements, so its frequency is broken. So now it's not 6 things at the same frequency, it's only 3 things at the same frequency, and then some new thing. So a frog would see it, but we're not going to see that photon now because it's broken. Alright, so the idea is the outside of a surface has got these electrons on it, and now the rest of these little bits are going to plow into those electrons. And as they're flying through here, they're going to start hitting the electrons, and the electrons are all in different positions in the atom. Like an electron could be over here when the photon comes, or it could be over here, you know, so it could hit it when it's in all kinds of different positions relative to the proton. It could be here or here. So if it hits it when it's straight on, well then it's going to create a very straight movement of the electron. But you could understand that when it hits it over here, it's going to create a very different kind of deflection, you know, because of the other electron's pressure. So the electron will move in all kinds of different directions dependent on its tension, what position it's in. So if you hit the electron, you know, if you hit with the electron being in the same line with the proton, it would be very different than when the electron's not in a line, and all the other possibilities exist. So you have basically 180 degrees worth of variation, okay, in the tension that the electron will be in when you hit it. So that means that there'll be 180 degrees worth of variation in the trajectory of that little bit. So these little bits are now going to go, like this one might go that way, this one will go this way, this one will go straight, this one will go that way. So they'll all go probabilistically different directions depending on what position the electron was in that they hit. So these two sources are now creating a bunch of diffraction, you could call it, but they don't like to use that word in any other context than waves, so I can just call it deflections or reflections, or I can call it just scatter. So the little bits are now scattered. So now the photons are really broken, okay? Tons of little bits flying in all kinds of direction. Now what they still have is their momentum. They're still, technically, when this one went this way and this one went this way, they're still traveling the same speed, so they still have their frequency, so to speak, the phase. They still left the same place at the same time and are going the same speed. So they're still carrying all their phase information. They haven't lost any of that. And so now all you're really going to do is say there's going to be 1,000 little bits are going to go here, and 1,000 little bits will go this way. And when they do that, you're just going to say, well, at this location they would all still have the same phase because these lines are the same length. And then I just figure out, well, what other lines are the same length? That is the same wavelength. One clear notch of wavelength. And so you can just do the math and figure out, well, this location and this location, these are the same notches again. The notches line up. The phase lines up. So I can reconstruct a photon there. And so all you're doing really is you're taking many photons and you're saying, I'll just take the element from this one, and another photon came through, I'll take this element, and another one comes through, I'll take that element, and as this one comes through, I'll take that element. So you're just putting a bunch of broken pieces back together again, and you're just saying, where are the places I can put this phase back together again? I can put a stream of bullets back in the right order. So all of them still have their phase information. It's still there. They're still moving the same speed, so you haven't lost anything. And all you're doing is saying it's kind of obvious that if I have 1,000 of them or 100 of them, then I'm going to be able to put back together 50 of the photons. I'll have 50 hits in a certain little space. Again, the atoms are going to collect them, so it's going to be 2,000 atoms of crystal that are going to get the impacts, and they're going to add up the impacts, and they're going to say, photon. All right, the crystal decides whether it got hit by a photon or not, because it's going to create a reaction. And the same is true with the reflections off of a surface. They're just going to reflect back the little bits they got at the right frequency. So when they get hit by enough little bits, the little bits bounce off at their frequency is still correct, and so now you have enough of them to rebuild streams of them that can be received as photons. Again, if you create too much polarization, too much spread, then you won't be able to receive them as a photon, because the receiver is still going to be your eye. Your eye has to see the little reflected bits and put them back together into a photon. They're not a photon until you collect them as a photon. Well, I don't know if that... the important fact is that we know this is just geometry, okay? That there's these locations where it's a full wavelength. Now, if it's a half wavelength, you know that now they're out of phase. So I put the photon back together, but I put it together out of phase. That is, there's clumps in the wrong places. And we know, just like our radio receiver, I need these clumps to be consistent. I need the distance to be this distance, not that distance, for it to be the photon that can be received. So if they're out of phase, then they're put together in the wrong distance from each other, and you won't be able to receive it. Especially if it's an erratic difference. Like one of them's here, really close to each other, then this one's here, let's say here, and then this one's close, but that is impossible to see. So so it's just geometry, and it puts them back together again at these certain angles. And the double slit is doing the same thing, except the two internal surfaces, as I pointed out. So this is my prediction. You'll always find this to be true, no matter how many you can do the experiment, all kinds of manipulations to the experiment. But what will be found to be true is that these two surfaces control the little dots. Okay, so it's close enough. So these two outside surfaces, this distance and this distance, they create the phase that makes the little dots, because these are much longer lines. Okay, so the longer the lines are you make, these lines, the more opportunity there is for in phase, out of phase, in phase, out of phase. So the further away these two get from each other, the longer the lines are in terms of their reach. And so there's more notches, and therefore more places where the phase can re-add up to in phase. But you have to have a continuous source of light. And so this whole idea of the single photon experiment, the problem is we only say it's a single photon when we see it. So we don't know that it's just one photon. It could be lots of little bits that are being thrown at the experiment, and it actually is, they never have one single photon goes through here or one single photon goes through here. It is true that more than one have to be going through, because you have to have bits coming from this edge and you have to have bits coming from this edge. So obviously more than one photon has to get to the surface. But again, this is just a measurement problem. We don't have any way of knowing how many photons we're shooting except to measure them as a where they hit. So those experiments can be done more precisely. See, what they should do is do the single photon experiment with no slits in the way, and see how many photons they get, and then they'll know exactly how much energy is there, and then put the slits in front of it and see if that much energy makes new photons, because that'll tell them a lot. But anyway, they never do these experiments, so there's no point in talking about them. So anyway, so the outside slits are merely controlling how big these little spots are. So if I make the outside slits further and further apart, I make these little blocks smaller and tighter, okay? And if I put them closer and closer, I make the blocks bigger and bigger. And so these two slits control these block sizes. And the two internal slit, these two, are controlling the background envelope. So they're making this light, and this light, and this light. So this light has to exist for these combinations. These little extra ones you're adding make it go light. So if it wasn't for the existence of these previous ones put at this location by the single slit here, if it didn't put that light there, you know, the little bits, when the vectors here and here came to it, they wouldn't be able to make a photon if the photon didn't already have a bunch of pieces that were put here by the interior slits. So the interior slits put pieces in all these locations, and then the exterior slits put a little extra going to these specific block locations, and that makes the extra that makes it visible. It wouldn't be visible without the underlying thing. So it is a composite of the two patterns. The interior slits making this light, okay, and then the exterior surfaces are producing the vectors, the possible vectors where they add more. So they just add more light. And that's how the pattern is created. So it is just a composite, not of the two slits, but of the two distances between surfaces. That's the composite. This distance and this distance, or what? This surface, this surface, this surface, this surface. These two are a pair, these two are a pair. And that's the critical bit. So anyway, the naysayers have said nothing to indicate how this doesn't perfectly explain the experimental outcome, that this theory does work. I would argue it's simpler, it's more mechanical, it makes more sense, you can draw it quite easily, and it works. And so I think it's the undoing of the conventional theory, and it's time to maybe write it up as a paper and submit it, because it's indestructible. It is consistent with the evidence. It does explain what's happening, and it doesn't have any woo in it at all. No magical wave functions, no having to create a new universe, no entanglement, no force acting on a force, no notion of photons or energy interfering with itself to create the pattern. You either reconstruct a photon or you don't. So the real theory isn't constructive and destructive interference. The real mechanism is break the photon, remake the photon. So it's just constructive reconstruction of a photon. Alright, so that's probably enough and such. So till the next time, we'll see if the Skyram guy has any integrity and can just man up and say, I misunderstood, or something like that. Just admit your aggression and your patronizing attitude was inappropriate. Because I have done what I claim I've done. I found a simpler, better explanation.